Hi everyone, today we will continue with another subtopic in chapter 5, Network in Graph Theory, that is directed graph and undirected graph. So first, we look what is a directed graph means. A directed graph is a graph in which a direction is assigned to the edge connecting two vertices. Directed graphs are usually used to represent the flow of a certain process. For example, road maps, airlines networks, electrical circuits, computer networks, and organization charts. Next, we look Diagram 1. Okay, this diagram 1 you can refer in your textbook, page 135. Diagram 1 shows a simple directed graph. Based on the direction of the arrows, it can be seen that for edge AB, the line that connects vertex A and vertex B, A is the initial vertex and B is the terminal vertex. That means A is the starting point and B is the ending point. So A, we label it as initial vertex and B, we call it as terminal vertex. For edge CB, C is the initial vertex and B is the terminal vertex. How you identify? You look at the arrow. Okay, the arrow is towards B. That means starting from C ends at B. All vertices are connected in one direction only. Okay, you can see that all the vertices are connected only in one direction. So this is diagram 1 is simple graph. Diagram 2 is a graph with multiple edge and loop. So diagram 2 shows a directed graph with a loop and multiple edge. Based on the directions of the arrows, it can be seen that E4, that means the line E4 is this from P to R. So you write in bracket PR, that means starting from P ends at R. So P is the initial vertex and R is the terminal vertex. Next, the line E5. Okay, E5 starting from R going towards P. So you write as in bracket RP. R is the initial vertex and P is the terminal vertex. Okay, next is E2. E2 is the loop. So for the loop, you write QQ because start with Q and ends with Q. Start and ends with the same point. So Q is the initial vertex and also the terminal vertex because E2 is a loop. So you will have an anti-clockwise and also clockwise. So next we look what is undirected graph. An undirected graph is a simple graph or graph with loops and multiple edges drawn without any direction being assigned. Okay, in other words, for you to better understanding, undirected graph you don't have arrow. Directed graph you have arrow. Now we look differences between directed graphs and undirected graph. You can refer your textbook at page 136, differences between directed and undirected graph. First, we look simple graph. So for simple graph, okay, for undirected graph, okay, the vertices, okay, as we learned before this, vertices is the point, okay, the dot here, A, B, C, D. So you write in form of set. Next, E, age. Okay, the first line here is AB. You can write as BA also. Next, AC. You can write also as CA. Next, BC. Then CD. So total age you have 4. So you take 4 times 2, you will get total degree is 8. Okay, how to calculate degree A? That means there are 2 lines that coming out from A, okay, that connecting the vertex A. So degree of A is 2. Next, degree of B. Okay, there are 2 lines that connecting vertex B. So you can write degree of B is 2. Then C, there are 3 lines that connecting vertex C. So you can write degree of C is 3. And for degree of D, okay, there only 1 line, okay, connecting vertex D. So you have 1. So total all the degree will be 2 plus 2 plus 3 plus 1 is 8. This is undirected graph that we looked before this. Next, directed graph. The vertices still are same. Okay, still you have vertices A, B, C and D. But now the A should have to follow the arrow. So now here, for this line, start from B, ends at A. So you have to write BA. You cannot write AB. Okay, you can read here the explanation given. The order of the vertices are written according to the direction of the edge BA, and AB represents different edge. So you have for directed graph, you have to follow the arrow given. So BA. Next, this line, okay, this line start from CA. Next, this line is B, start from B, ends at C. This line, the last line, start from D, ends with C. So you write DC. For degree, for directed graph, you have 2 types of degree. One is degree in, another one is degree out. What is degree in? That means when the arrow comes into A. Degree in for vertex A is the line, okay, with arrow that comes into A. So for A you have 2 lines, and both lines, okay, the degree in, because both arrows are coming into A. So degree in A is 2. Degree out, that means the arrow is going out from A. There are no lines, okay, with the degree out. So degree out A is 0. From here, you calculate total degree of vertex A. That means 2 plus 0, you will get 2. You can read the explanation of degree in and degree out. Degree in of vertex A means the number of edge going into vertex A. And degree out of vertex A means the number of edge coming out from vertex A. So same goes for degree in B. So for vertex B, you have 2 lines also, but the arrow is going up from B. Okay, going up from B. So degree in is 0. Degree out, B is 2. Next, we look for C. Vertex C, you have total 3 lines. Out of these 3 lines, two of the lines, okay, the arrow is coming in, and one of the line, the arrow is going out. So, degree in C is 2 because 2 arrows coming in, and degree out C is 1. Okay, 1 arrow is going out. Next, we look for D. You have only one line connecting vertex D. So and the line is going out. So degree in for vertex D is 0 and degree out of vertex D is 1. So you sum all the degrees, you will get the sum of degrees is 8. Next, we look for graph with loops and multiple edge. For undirected graph, before this we already learned. Vertices, we look at the dots given P, Q, R, S, T. These are vertices. Next, edge, okay, you can write as PT this line, or you want to write TP also can, because there's no arrow. You can start either from P or T and ends with P or also T. So the line you have is PT, PQ, multiple H, QR, QR, then QS, ST, loop, TT. So these are the H. So total number of H that you have is 1, 2, 3, 4, 5, 6, 7. So sum of degree, you can use 7 times 2, we get total 14, or you calculate 1 by 1. Degree of P, that means there are 2 lines connecting vertex P, so degree of P is 2. Degree of Q, there are 4 lines including 2 multiple edge here, so degree of Q is 4. Degree of R, there are 2 lines, multiple edge, okay, connecting R. So degree of R is 2. S, also 2 lines connecting vertex S. So degree of S is 2. Next, T, you have loop. Okay, always must remember and take note that loop has degree 2. Okay, the degree of loop is 2. One is clockwise, another one is anti-clockwise. So degree of T will be total 4. And you sum all the degrees, you will get total 14. This is for undirected graph. Next, for directed graph. Directed graphs, for vertices still same. You write out the dots P, Q, R, S, T. Now for edge, you have to take note, for directed graph you have arrows. So you have to follow the arrows. So from P to Q, the arrow is starting from P and ends at Q. So you have to write PQ. Next, the multiple edge. Okay, the one side start from Q ends at R, then another side start from R ends at Q. So your multiple edge, okay, how you write the edge is QR, RQ. Okay, follow the arrow. Next, SQ, start from S, ends at Q. Then TS, start from T, ends at S. Loop, start and ends at the same point, same vertex. So TT, then the last one is TP. So total age you have is 7 also. So either you use your formula 2 times 7, you get 14, or you can calculate 1 by 1. Now we look for degree of vertex P. So degree in. For vertex P, there are two lines connecting P. So for one line, the arrow is coming in and another one is coming out. So degree in P is 1 and degree out P is 1. Okay, for Q, there are 4 lines connecting vertex Q. So out of these 4 lines, 3 lines are coming in. That is SQ, PQ, RQ. And only one line, the arrow is going out. So degree in Q is 3 and degree out Q is 1. Next, for R, there are 2 lines connecting R. So one line is going into R, another one, the arrow is going out. So degree in R is 1 and degree out R is 1. Next, for S, also there are 2 lines connecting S. That is, one line is coming in and another one, the arrow is going out. So degree in S is 1, degree out S is 1. Then for T, T you have 4 lines actually, okay? Okay, for TS going out, TP going out. But loop, you must remember for loop, okay, for loop always degree in 1, degree out is 1. Okay, remember now, degree in is 1. That means there are 2 directions for loop. One is clockwise, another one is anti-clockwise. So degree out is 1. Okay, this is for loop. Okay, the arrow will be, they never show arrow for loop, but you must know for loop, there is a degree in 1 and degree out 1. That's why, okay, it's written here, loop. Okay, for degree in T, you have 1. And degree out T, you have 3. 1 comes from the loop, 1 is from the line TP, 1 from the line TS. Okay, take note, loop, you have 1 degree in and 1 degree out. So total sum of degree is 14. Next, we look differences between weighted graph and unweighted graph. So you can refer this table in your textbook at page 137. Weighted graph. So first type of graph for both are same. Okay, for weighted and unweighted graph, you can use directed graph or undirected graph. Age. For age, weighted graph, the age is associated with a value or a weight. That means there will be a value at the line of the graph. But for unweighted graph, not associated with a value or a weight. That means there will be no value given at the line of the graph. So example of weighted graph, the age represents distance between two cities, traveling time, the current in an electrical circuit, or cost. An example of unweighted graph, the age relates information like job hierarchy in an organization chart, flow map, tree map, or bubble map. Now we look example 7 at page 137. So what they ask you to draw a directed graph based on the given information. So we look part A, given vertices P, Q, R, S, T, U. and the age is PQ, PR, RQ, SR, SQ, ST. So, how we draw PQ? This is a directed graph. So, PQ, that means the line should be start from P to Q. Sorry, the arrow should be going up from P to Q. Okay, how to draw? Okay, for get better understanding. Okay, as I told you before this, okay, what you can do, you can draw the first step. Okay, your first step. Okay, you draw the or you mark the vertices. That means total vertices that you have is P, Q, R, S, T, and U. Now, you draw the edge. After you mark the vertices, you draw the edge, PQ. Then you draw the arrow, PQ. Start from P, ends at Q. Next, PR. Please use ruler to draw PR. Next, RQ. R to Q. Then SR. Please use ruler. Please use ruler. SR, SQ. To SQ, ST. So in this case, U is not connected. Okay, U is not connected, but don't forget to draw the vertex U. Must draw. Okay. So this is the example of graph. You can draw first, you draw the vertices, then only draw the edge according to the given information. So for part B, they give, okay, there is a loop at vertex Q and RS is a multiple edge such that degree in P given degree in and degree out. Degree in P is 1, degree out P is 1, degree in Q is 3, degree out Q is 2, degree in R is 0, degree out R is 3, degree in S is 3, and degree out S is 1. So how we want to draw? As usual, okay, first step, what you must do, you draw the vertices. You mark the vertices first, P, Q, R, S. You have total 4 vertices here. Then, you are given the information that there is a loop at vertex Q and RS is multiple edge. So this is a plus point for you. So you draw the loop at Q and also you draw the multiple edge connecting RS. So after that, okay, from here, okay, you can draw degree in P1 and degree out P is 1. That means total line here should be 2. For degree P, you must have 2 lines. So what you can do, the easiest, you draw P and Q. So one is going out, one is going in. Next, for Q, you must have 3 plus 2. That means total line that connects Q, total line should be 5. So please take note, for loop, it is always the degree you calculate as 2. That means you already have degree out 1, degree in 1 loop. So total line that you are going to draw for degree out is 1 and degree in is 2 after you minus the loop. So now, where you want to connect? Okay, already P to Q coming in into Q. The line PQ coming in. So you already have 1. That means you're going to draw another degree in. That means another line. Either you draw QR or you can draw QS. Okay, so you want 1 in, 1 out. Okay, so for degree R, you take note that degree R, you cannot draw into R because it is 0. So for degree R, you have to draw out of R. That means for R, you have to draw out like this. So in Q already complete. So for QS, it is going out. From Q going out to S. Next for R, you already have 3 lines. Okay, total lines you have 0 plus 3 is 3 lines. Okay, including the multiple edge. Okay, one is RQ. These 2 lines also you must draw degree out. That means the arrow must going out from R. Then for S, degree in is 3. Okay, we just check. Okay, for S. 1, 2, and 3. Okay, 3 lines are coming in and 1 line is going out. So we look the answer now in your textbook. This is how you get the answer. Okay, you draw one by one. You draw the line one by one. Okay, next we look example 8. The diagram on the right shows one-way path that Izarul can choose for his running practice. Vertex V1 is the starting position and vertex V5 is the ending position before he goes home. So now we look the diagram given. You have V1, the vertices, V1, V2, V3, V4, V5. So the question short distance from V1 to V5 and longest distance from V1 to V5. So before you find the answer, you must know what is the way from V1 to V5. How many ways you have? So from V1, you can go to V2. Then after V2, you can go to V3. Then you can go to V4. Then we can go to V5. So from V1 to V2, the distance is 600. Okay, you plus with V2 to V3 is 900. Then for V3 to V4 is 500. Then from V4 to V5 also 500. So we add up all this. So 600 plus 900 is 1005 plus with another 1000 will be the total distance for this way is 2500 meter. Given is meter. So that means it's 2.5 kilometer. Okay, I hope you all know how to change 1 kilometer equal to 1000 meter. So 2500 meter is equal to 2.5 kilometer. Next, we look what are the other ways that we have. Okay, from V1, still you can go to V2, but now you are not going to use V3, but you will use V4. That means you are going straight away to V4. Then you can reach V5. So again you calculate the distance. So V1 to V2 is 600. Then V2 to V4 is 800. Then V4 to V5 is 500. So you calculate the total distance from V1 to V5, 600 plus 800, that is 1400, plus weight 500, that is 1900 meter. So that means when we change to kilometer, it becomes 1.9 kilometer. Then we also have another way. Okay, from V1, still we go to V2, but now we didn't go to V3 or V4. Straight away we can go to V5. Okay, there are another way that we can go straight away to V5. That means V1 to V2 is still 600, but V2 to V5 is 500. So total distance will be 1100 meter, that is 1.1 kilometer. Then we also got another way, that is V1. We didn't go to V2, but we go to V3. Okay, look at the arrow. We can go to V3. After V3, there's no other way. You must go to V4. Then from V4, you can reach V5. This is another way. So from V1 to V3, the total distance is 500. You refer to the graph given. From V1 to V3 is 500. From V3 to V4, also 500. Then for V4 to V5, also 500. So now we calculate the total distance is 1005. That is 1.5 kilometer. So from here, we already can get all the answers for part A, part B, and part C. Part A, the shortest distance from V1 to V5. So what is the shortest distance? Is this one, 1.1 kilometer. So the shortest distance is V1 to V2 to V5. Next, okay, this is for the shortest distance. Next, for the longest distance. Longest distance, which is the longest distance that getting longest uh, a kilometer. You got the longest, that is 2.5 kilometer. That means you start from V1, you go to V2, then V3, then V4 and V5. Then next, for part C, vertices that must be passed through if the distance of the one-way run is between 1.4 kilometer and 2.1 kilometer between. So what is the distance that is between this number 1.4 and 2.1? That is 1.9 kilometer and 1.5. That is V1, V2 to V4, V5 is 1.9, and V1, V3, V4 and V5 is 1.5. So we can check the answer. Okay, the shortest distance V1 to V2 to V5 is 600 plus 500, correct? No? It's 1,100 meter, that is 1.1 kilometer. Next, longest distance is V1 to V2, V3 to V4 to V5, correct? No? 2.5 kilometer. Then the part C, the vertices. So the way that I highlighted in the green, V1, V2, V4, V5, and V1, V3, V4, V5. Okay, so that's all. I hope you all can understand the uh, topic that is given to you. So thank you.